Today we're going to be doing an extensive end-to-end data analysis project using Python. Now if I open up this link here, we'll find a data set of most streamed Spotify songs for 2024 on Kaggle. Now this is a great data set. You can see there's a lot of people who've contributed to the discussion, the code, and there's a good description here. Equally, it's got 10 on the usability score, so let's get to it. Now, these are all the columns that are going to be available. Take a quick look at these to understand them, and then head over and hit download. Once you have done, I unzipped the file and stored it here. So, I've saved that, I've saved this, and in fact I already have the script. Now, whichever Python environment you want to use, it doesn't particularly matter. In our case, I'm going to use Jupyter Notebook, and so to access that, I'll open up the terminal in this folder location and type Jupyter Notebook. To install Jupyter Notebook, again, you can do that in your terminal here. It's not too complicated, it's very quick. Just Google how to install Jupyter Notebook, and you'll be there very shortly. Now, I'll share with you guys this notebook as well, but alongside going through it, I'm also going to go step by step exactly what it means. Now this is pretty extensive. We're going to end up with this as the result. A lot of charts. In fact, we'll even finish with some machine learning, starting from the basic imports, looking at the first few rows, just some descriptive statistics, visualizations, looking at the correlations in a correlation matrix with a Seaborn heat map, and then finishing with here the machine learning. So let's get right into it. Now, what I'm going to do here is open up another notebook just so we can run each of these individually and see exactly how they work. So let's just call this demonstration. Perfect. Now I'm going to try and do this with as little cuts as possible so you can see a live walkthrough and try and explain everything to the best I can. Now, I don't know how familiar you are with all of these concepts, but this should work whether you're a beginner or have been doing this for some time. So just to explain to everyone who isn't familiar, when analyzing data or working with Python, you first need to import your libraries. Now we use pandas for data frame manipulation, Matplotlib for visualization, and Seaborn to build on that with statistical plotting. Now to use these, we need to import it. So we simply type in import pandas and then we give it a name to reference it here as PD. But before we can even do that, if you've never done this before, make sure you install the libraries. So with pip install pandas, just like that. Once that has run here, it will say requirement already satisfied because we already have pandas. There we go. And now I can import it with import pandas as PD. It'll take a moment and then we can start to use pandas. Now, if we look at the name of this file over here, it's the most streamed songs in Spotify 2024, and I can see it's a CSV. Now, typically, if we wanted to load this, we would just type df equals PD, referencing that pandas, dot read, it's a CSV, and that's the name of the file, .csv. There is a problem in this case. Now, it's a very specific problem that you won't usually encounter. It's an encoding error with the file. Now, to get around this, we've just specified how we want to encode it. I just want to clarify that won't usually be the case. Now, let's enter in the correct file with the appropriate encoding, and there you go. It's very quickly done that. So what I'll do next is look at the data frame. We haven't actually really explored it yet. So df, that's what we stored the data frame as, the CSV, dot head. Here we can see the first 5 rows. Now bearing in mind, it does say here there's 29 columns, 5 rows, but indexing starts at 0. So this is 0, but 1. You could look at more just by typing a number in there. And this is now the first 10 rows. We can see there's a lot of great information here. I mean, it's really comprehensive. I know there's 29 columns. There's not only 10 rows. The best way to see the actual size or shape of the data frame is to type df.shape. You don't have to put the brackets at the end of that, but we have 4,600 rows. This is a huge data set, 29 columns. There's a lot to explore here, which is brilliant. So let's get right to it. What you can see is I looked at the first few rows, I imported the data, I've shown you the shape, and then we want a little bit of information and then to describe it. So to get the information about the dataset, we type df.info. Here we can see whether there's any null values. Now we know overall there are 4,600 rows. So with the track column, there's 4,600 non-null values. Here there are some null values. We can see that. But that's okay, we'll deal with that later. If you did type in something else, such as describe, we can look at the descriptive statistics for each of the numerical columns. So track score has an average score of, or mean of, 42. Standard deviation of 39, a minimum. You can look at the quartiles and the maximum, and that is the case for each of these columns. Now, this column here looks like it actually might be entirely blank. So we can take a look at that here with df.info again. Title popularity, yeah, 0 non-null. So that entire column has nothing in it. So we can just remove that altogether. Here's where we actually look at the missing values per column. And to do that, we can type df.isNull.sum. This will give us a total count of how many null values there are. So df.isNull, call that method, and then sum it all up here. So rather than seeing it the non-null, it's quite hard to see it that way. It's a little bit easier to read it like this. Now, title popularity, of course, has the most null values. It's entirely null. There's quite a few in other areas as well. Now, SoundCloud streams has over 3,000 null values. That's something we might just drop altogether, but we're actually going to attempt to clean it up first. So let's do that. Here we drop title popularity, meaning we remove that from a column, that's axis 1, and we run in place equals true. I just want to show you exactly why we do that. So if I did not have in place equals true, and I drop it from the columns, again, axis 1, brilliant, it's dropped it. You can see it's not in here anymore. However, later on, if I call the columns again or look at the data frame, you should see that it's still in there. But I just dropped it. Well, no, I actually just dropped it for this cell. To drop it all together throughout the entire workbook, I have to type true. And now when I call this, you'll see it's gone. Fantastic. So that's another important thing just to bear in mind. Equally, when you look at the df.info, it's very useful not just to see the null values, but also the data types. Now, some are objects, others are floats, which are decimal values. Integers like this would be whole numbers. But some of them are incorrectly assigned, like release date. Well, that should be a datetime object, not an object. So we can correct that, and we do this here. We look at the column df release date. Now, by typing just this alone, it will return just that column. Here are all the values. But then we set it equal, or we assign it to pandas, and we call a method called toDateTime. So it just converts it. And this just allows it to be easier manipulated. So let's do this here. Let's copy that in. Fantastic. And there we go. So now if I called df.info yet again, you'll see it's now a datetime object. Brilliant. So we can manipulate that now. Let's take a look at what I did next. So just to quickly recap what we've done so far, we've loaded in the dataset, imported pandas. We're not worrying about the rest for now. These are all for machine learning, so that's right at the end, and these are for visualization, which we'll look at next. Because for now we're just doing EDA, that's exploratory data analysis. So we've loaded it in, we've seen how many null values there are, the data shape, we've even taken some of the columns and changed their data types. But let's look at those null values again. Where is that? Here. That's great. We know how many null values there are, but there's another error you can have when cleaning your data. That's duplicated values. So to take a look at how many there are, instead of typing df.isNull.sum, you type df.duplicated.sum. Two rows are exactly identical, which means we can probably drop that. Bearing in mind, we'll want to keep in place as true, as we covered earlier. So df.drop duplicates. Now, if you hit tab, it can actually show you all the available options. So we'll just select duplicates here, and we'll put in place equal to true. Perfect. Now, here's the point where we want to get to some visualization. So you can see instead of PD, we've called PLT and SNS. This is Matplotlib and Seaborn. So let's get right to that, because if I just try to run this now, you'll note it'll return an error. PLT is not defined. Okay, well, let's import that. PLT, and then import Seaborn as SNS. What you refer to these as don't really matter. These are just very common conventions, and this is what you'll see it as almost anywhere. Now, if we rerun this again, which, and I should have mentioned, you can either do by pressing this up here or holding Shift and Enter. There you go, we've got our visualization. Now, I've run through that very quick. Let me explain that a little better for you here. What I've got here is just something to configure the actual size of the plot. You don't need that. If I ran it without it, it'd just be a little bit smaller. So let's exclude that for now, just to simplify it. This is a hist plot, a histogram. Now, a histogram is a bit like a bar plot, but it puts things into bins. Here, 30 bins. We've put KDE is equal to true. That's just this line there, just to show the general shape of it. You can see this is positively distributed. Then we just label the axis. Again, you don't even need that if you didn't want. You could simply run this and it would just say count of track score. But we wanted to be a little bit more descriptive, so we specified the title, changed this to frequency, and kept that as track score. Brilliant. Well, we're getting on very well. But what if I wanted to do something a little bit more complex? Rather than analyzing just the data that was there, I want to analyze data that isn't there. So here we can extract the release year from the release date that we recently changed to a date time column. And again, in the pandas data frame, which we've named DF, we look at the release year column and we change it to just the year rather than the full date. After we've done that, we can then plot the number of songs released each year as a bar chart, setting the figure size or how big you want the plot to be, sorting the index of the bar plot so it's just biggest to smallest, and then giving it some labels. So again, let's run this in our demonstration file, and here we go. So, not biggest to smallest, it's an order of year. So you can see that here there are no values, you actually probably could drop that. We get some in 2000, and it increased the most songs released were in 2023. It then sort of returned to the mean here in 2024, but there is this gradual increase in number of our songs by year, which allows us to answer some questions. Are there more songs released now than ever before, or are they just better documented? Are we keeping track of what songs are released more efficiently with systems like Spotify? And if this is just looking at Spotify, well, I'm imagining that Spotify did not exist in 1987, so the majority of songs wouldn't be on there now. Okay, so back to it. This is a brilliant plot. This is a correlation matrix. And we can use this to look at the selected features here. We've just looked at these in the data frame to plot a heat map. We've put a not is equal to true. This will all make sense in a second. A not is equal to true allows us to see the values in the heat map of how correlated or positively correlated those values are. CMap is just the color. We want to keep cool warm from blue to red. And we've put a title on it as well. So let's run that. And here we go. You can see actually these values here are 100% correlated with themselves, which makes sense because track score and track score are the same thing. Other things are less correlated. Now, Apple Music playlist count is actually quite correlated with Deezer playlist count. It's interesting. Whereas Spotify popularity seems to have very little, if any, correlation to the track score. So again, this just allows us to answer questions. I mean, here is quite low again. So track score and Amazon playlist count, not really correlated too much. But it's just interesting to see that. And all of this is an EDA, exploratory data analysis, and it's just about bringing up a question and exploring potential answers from the data we are given and seeing what data we might want going forwards. So what we do next is yet another visualization. This is actually the final visualization. So don't worry, we'll get into some more data cleaning here. And then shortly, the machine learning, which is very popular now. A lot of people love machine learning in a portfolio project given the popularity of AI, which has come across with ChatGPT and so forth. So let's group by artist. You can see I use the group by function here, artist and track score, to look at the mean values, and I sort it ascending equals to false, and we're just looking at the top 10. So that might not make too much sense. To explain that a little better, you can see I've left a comment here that says we're going to plot the top 10 artists with the highest average track scores as a horizontal bar chart. And again, we're going to set the title with PLT or Matplotlib, the X label and the Y, and the figure size here as well. So let's just run this again just to prove it all works in our next workbook. And here you go. Horizontal bar chart with the top 10 artists, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's plotted it by the average track score. So, anyone you recognize here? Kids with Buns. I don't personally know who that is, but you can see their average track score is around 300, which is the second highest. Now, continuing on to the next stage, we're going to want to clean some columns. I don't want to clean all of them, just these specifically. And so to do that, we're going to list those columns in a sub-data frame. We're going to list them out inside these square brackets with quotation marks, as we have done previously when we're calling a column. But again, just put some commas to separate them. So for all of these columns, I'm going to assign them to columns to clean, that variable. What I'm next going to do for each of those columns, and this is just some syntax in Python for columns in columns to clean, meaning each of the values in here. We want to convert the column to a string, remove all the commas, and convert to a float value. Now, we discussed float values earlier. So replace commas with nothing. That's removing the commas. We're going to set type as float, and we're also going to change to string as well. So let's copy that here. In the demonstration file, let's hit enter. You won't see anything because this is all done behind the scenes. That's really how Python works. But something has happened. Now, there are still going to be values which are missing after we've cleaned it up. So we're just going to want to drop all of those. So df is assigned to dropping all the NAs. So df.drop NA. Let's run that. And importantly, you could also fill the NAs to impute the missing values. That means you could put the mean, mode, or otherwise, or if you knew the specific value for something, you could fill that as well. We're not going to do that here. We're actually going to get into some of the machine learning now. Now, this is a supervised machine learning model. And what that means is we have all the data And don't worry, you'll see this working in a second. But we break it into two parts. A training set, which is the majority of the data, and then a test set. Now, the test set's normally about 20%. You can see that's what we've done here. And it's just used to evaluate how well our training set did on training the model. That's how you might hear people saying, we know that our model is 80% accurate because they've tested it internally. Now, what we're going to do is use this to build a predictive or classification model. Here I did predictive with linear regression, but again, this is getting way ahead of ourselves. Let's get straight to back where we were. We've cleaned the columns. We've done some visualizations, some manipulations as well. We've loaded in the data set. We've got this set up. We are good to go. We've also dropped the NA values. But in machine learning, there are features and a target. Now, the features are the independent variables. Everything used to predict the dependent variable, the target. So we want to use all of these columns to predict the track score. So we assign each of these accordingly. We then officially assign it here. So the X and convention in machine learning is X is capitalized. X is assigned to the features and Y the output. With that in mind, we can then split the data, which is what we've just spoken about, into the training set and the test set. So we have X train, X test, Y train, Y test. Now that's a train test split, which is what we just discussed. Pulling in the X and the Y, assigning the test size to 20%. And then we have something called a random state. Now a random state, all that does is it means every single time this is run, it produces the exact same results. So let's copy that in. But before we get to that, let's ensure we have all the right imports. So let's get all of these in. Now, what we have additionally is sklearn, also known as scikit-learn. We're going to import the train test split. We're going to import the specific model, which is linear regression. We're going to want to evaluate how well we did on that test set. So we'll use these two metrics here. You may have heard of them before. You may not have. Don't worry about it. They're just evaluation metrics. Mean squared error and R2 score. And we want to standardize all our values as well, so they're on the same sort of scale. So let's hit run. While that's doing that, let's pick up the next stage, which is what we just walked through. So let's see where we got to. We got all the way up to this here, dropping the NA values. Now, let's copy this over and this. Perfect. And when I hit run, again, it looked like nothing happened. Then we're going to initialize a standard scalar. Now, this isn't always required. In our case, we're just going to transform the X train and the X test just to standardize those variables. So let's copy that. Once we've done that, we're then going to initialize the linear regression model, meaning we're going to assign linear regression to model. And we're then going to fit that linear regression model, model.fit, with the scaled X train data and the Y train data. And you're done. Not only have you just created a machine learning model, but you've trained it, and now you can make predictions off that scaled data. I know this is quite complicated, and you don't need to go this far. You could just finish at the EDA earlier, but let's just run through it and see what we get. So we're going to make a prediction on the scaled test data. We're going to assign that to ypred, y predict. That is just the model predicting for the target prediction on the X scale data. Remembering X and Y does relate to these here. Now that that's done, we're going to evaluate the model with the mean squared error, which is just assigning it to these just to make it a little shorter in the variable names, and the R2 scored for the target features and the test and predict. This here is just some formatting. You could just print out MSE and R2, but don't worry about that. It's an F string, meaning it calls that variable inside of this text as well. But if we hit run, let's allow it all to load. This is doing everything that we've just spoken about rather than going through the documentation or demonstration one by one. And here's the output. So let's take a look. These are the first few rows of the dataset, the first 5. Here are some manipulations we did, including looking at the tidal popularity, which was all 0. Now, we looked at the shape of the data frame, but we also, which is here, looked at the info, the dataset info. We looked at the dataset description for descriptive statistics. And we also looked at missing values and duplicated per column. There was 2 duplicated rows, and we cleared those out and sorted for all of those errors as well. You'll be familiar with each of these plots. We've gone through them one by one. And then let's go back up here. We want to print out these evaluation metrics. So here we go. Now, in terms of what these actually mean, well, let's take a look. What is the mean squared error linear regression? You can always Google little things like this. This shows you how close your prediction is to your data points. In fact, we can get even more specific and use AI to evaluate our AI model by going to ChatGPT, Bard, Gemini, or otherwise, and type in, what does this tell me for a linear regression ML model? And it will tell you specifically what these values mean. Now, I always recommend with this, do double check what it outputs because it can hallucinate, but it's good to see. So here it's telling us that a lower MCE indicates a better fit. And that's right. The R squared, yes, is a statistical measure that represents the proportional variance. And this tells you correctly that 43% of the variance of the dependent variable is explained by the independent variable. The rest is unexplained, suggesting there might be some other variables or factors and features in the model that we haven't looked at. Brilliant. It even indicates next steps, which is fantastic. But as I said, this entire script, I'm going to close this down now, just to make sure I haven't manipulated it, is going to be just how it was in the video, and you guys can access it in the link below. Now, all the best and good luck.